So hello my dear students, in this video I will be discussing some questions from exercise 3.1. So here is the first question. You have been given some figures and the question is that out of these 8 figures you have to find out which of them are simple curve. Okay, now what do you mean by simple curve? A curve that does not cut itself. Okay, suppose if I am drawing like that, okay, this is a curve, okay, this is also a curve, so it is not cutting itself. Okay, suppose if I draw curve like that, so this curve is somewhere here, it is one part of the curve is cutting the other part. Okay, so this type of curve is not simple, okay, but this type of curves are considered to be simple curves. So from the given figures you have to point out which of the curves are simple curve. So this is a simple curve, this is also a simple curve, but what about this one? See, you may say that they are not cutting themselves, but what is the problem with this figure is that why it is not simple? Because this figure consists of two curves. Okay, so it cannot be considered to be a simple curve because it is having two curves. Okay, that is why it is not a simple curve. If you consider the two curves to be isolated, two different curves, then each of them is a simple curve, but since the entire figure consists of two curves, we cannot consider it to be a simple curve. Again, this one, it's also not a simple curve because they are cutting, it means one part is cutting the other. Okay, this again is a simple curve, this is a simple curve, this is a simple curve. So which will be the simple curves? 1, 2, 5, 6 and 7. Now coming to the next one, simple closed curve. It has to be simple as well as closed. So this is simple, it is closed also, it is simple, closed, it is simple, closed, it is also simple but closed, it is also simple but closed. Why this figure is not again a closed curve, okay, or simple curve? Because here it is, here totally you are not having one curve, you are having many curves. Okay, here you are having two curves, that's why it is not considered to be simple curve. Here also you are having these two curves, again one more curve is there. Okay, so that's why it is not simple curve, it is not a curve, isn't it, simple curve, and not also a closed curve because these two are different and again these are being joined by this one. So this is also not a simple closed curve, it's not a simple curve, that's why it is not satisfying the case to be a curve only, simple curve, then the question of simple closed curve does not arise. So here also simple closed curve will be 1, 2, 5, 6 and 7. Now coming to polygon, this sixth C part is polygon. You have to find out those figures which are polygons. Now what is a polygon? A polygon is a closed figure made up of line segments only. So see this one, it is a closed figure and it has only line segments. So this is a polygon. Here again made up of line segments, it is a polygon. This and this we cannot consider to be polygons. This is not polygon. This is not polygon because they are cutting, isn't it? The one side is being intersected by other sides, so it is not a polygon. Here it is closed curve but it is not a polygon. Why? Because it is made up, it is not made up of line segments. You are having this type of curve here, these are not line segments, so we cannot consider this to be polygon. Again this one is a closed curve but not a polygon because see, you can consider these two sides to be line segments, but what about this? These are curves, okay, these are curves which are not line segments, so this is also not a polygon. So which one can be said to be polygons? This one is polygon, this is polygon and none. Other than these two, we don't have any polygon in this figures. Okay, so polygon gone. Now convex polygon. So all of you know what is a convex polygon? A polygon which has all the angles less than 180 degree. See this figure, this is an angle of the polygon which is greater than 180, that is the reflex angle, so it will not be a convex, it will be concave. But here all the angles are less than 180 degree, so it will be concave. So sorry, this will be convex and this will be concave. So when they are asking convex, we will write only number 2. When they are asking concave, we will write number 1. So with this we have completed question number 1. So students, here is the second question. How many diagonals does each of the following have? Question mark. Okay. First is a convex quadrilateral. Now all of you know what is a convex quadrilateral. We have discussed many times, isn't it? So this can be a convex quadrilateral. See, I am having 4 vertices A, B, C, D. Now you know what is a diagonal, means which joins two non-consecutive vertices. So here only these 2 diagonals are possible. So in case of convex quadrilateral, see, we are having only 2 diagonals AC and BD. They have asked about convex quadrilateral. If they would have asked about concave quadrilateral also, then also in that case only 2 diagonals are possible. So here we can write that it has 2 diagonals. Okay, 2 diagonals. Okay, I can write it 2 diagonals. Now coming to the next one, a regular hexagon. What is a regular hexagon? Means a hexagon that is having means a polygon having 6 sides. They have included this word regular, means all the 6 sides and all the 6 angles of that polygon are equal. Okay, this, all the 6 sides 1, 2, 3, 4, 5, 6 are equal. All the angles are also equal. So this is a regular hexagon. Now they are asking us that how many diagonals can we draw. Okay, suppose A, B, C, D, E, F. These are our 6 vertices. Now if I consider, let's rub this so that our figure becomes clear. Okay, so if I consider the vertex A, B and F are the consecutive vertices. So leaving these 2, I will be joining all the other vertices. Okay, so from A we can draw, yes, 3. So what are those? AC, AD and AE. We have drawn 3 diagonals from the vertex A. Now coming to vertex B. So A and C will be the consecutive vertices. So I will be joining all the non-consecutive vertices. BD is there, BE is there, BF is there. Okay. Now considering C, from C, B and D seem to be the consecutive vertices. So leaving these 2, we will be joined. CA already drawn, CE, CF. I am joining CF. Then we are having CE, CF, CE. Okay, done. CF, CE. Now considering D, E and C are the consecutive vertices. So I will be joining DB already drawn, DA already drawn, DF. So DF. Okay. Now considering the vertex E, F and D are the consecutive. So this already drawn. Considering F, FD, FC, FB already drawn. Okay. So ultimately 1, 2, 3, 4, 5, 6, 7, 8, 9. So ultimately we have got 9 diagonals in a regular hexagon. 9 diagonals. Now coming to triangle. Suppose this is our triangle. See here, we know that diagonal joins two non-consecutive sides. So for the vertex A, B and C both are the consecutive vertices. Do we have some other vertex? We don't have. So how can we draw the diagonal? Similar is the case for vertex B and C also. So we cannot draw any diagonal in a triangle. So we can write no diagonals. Okay. So with this we have completed second question. Here students, I would like to give you a small hint. Okay, suppose you are having the question, suppose they are asking you in a regular decagon or in a regular octagon how many diagonals are possible. So it will take a lot of time to find the number of diagonals by drawing the figures, isn't it? Suppose the question is for 1 mark, you cannot spare so much time. So there is one short method. Okay, that formula is, I am just telling you the formula. You can apply that formula in case of MCQs. Okay, when it is asked for 1 mark only, just you have to write down the answer. In that case you can apply this formula. It is given by number of diagonals is equal to number of diagonals, you can write, of a polygon having n sides. Okay, having n sides. It is given by the formula n into n minus 3 by 2. N into n minus 3 by 2. See, just consider the case of regular hexagon. It is having 6 sides. So here n is 6. So 6 into 6 minus 3. In place of n you just put 6. 6 minus 3 gives you 3 by 2. 2 3s are 6. Ultimately you are getting 9. So this way you can find out the number of diagonals in any type of polygon. Means a polygon having 10 sides, 20 sides also you can find out the number of diagonals without drawing the figure. This is just a simple formula. Number of diagonals of a polygon having n sides is given by n into n minus 3 by 2. So students, here is the third question. What is the sum of the measures of the angles of a convex quadrilateral? Will this property hold if the quadrilateral is not convex? Now, the sum of the measures of the angles of a convex quadrilateral, just we have learned from the angle sum property that the sum of all the angles, see, suppose this is a convex quadrilateral A, B, C, D. Okay, in this case the sum of all the angles will always be equal to 360 degree. How we proved that one? Just while discussing the angle sum property we have proved, isn't it, how the sum of all the angles is equal to 360 degree. So just like that you will do here also. Okay, considering this to be 1, 2, 3, then this one 4, 5, 6, we can consider that the sum of 1, 2 and 3 is 180 degree, and 6, 4, 5 is also equal to 180 degree. So if we do the sum of all the angles we are going to get 360 degrees. So it is a case of convex quadrilateral. Now they are asking whether this property holds for other quadrilaterals also which are not convex. Not convex means definitely it has to be concave. So if we consider one concave quadrilateral, A, B, C we have considered. So let us consider E, F, G, H, isn't it? Here also we can draw EG, line segment EG, so that again here two triangles are being formed. We can consider this to be 1, 2 and 3, this one to be 4, 5 and 6, and then again considering the triangle EFG, we can say that 1, 2 plus 1, 2 and 3, the sum of 1, 2 and 3 is equal to 180 degree. Angle 5 plus 6 plus 4 is equal to 180 degree. When we do the sum of both of this, we are definitely going to get the sum of all the angles to be 360 degree. So yes, the property of this one, that the sum of all the angles, angle sum property of quadrilateral, it holds for both convex as well as concave quadrilateral. Okay, so here while writing the answer, what will you write? What is the sum of the measures? The sum of, you just write the sum of the measures of all the angles of a convex quadrilateral is 360 degree. Will this property hold if the quadrilateral is not convex? Yes. And how you will show? You will draw a concave quadrilateral and mark these angles as 1, 2, 3, 4, 5, 6. Then you will write that in triangle EFG, angle 1 plus angle 2 plus angle 3 equal to 180 degree. In triangle EGH, H, angle 5 plus angle 6 plus angle 4 is equal to 180 degree. How 180 degree? By angle sum property of triangle. Now from these two equations we are getting this thing that if we now see, this is one equation, this is one. I am adding both the equations, 1 plus 2 plus 3, and here 5 plus 6 plus 4 all. So these two, 180 plus 180, 360 degree. So if I consider 1 and 5 together, 1 and 5 together, I can get angle E. Now what about angle F? It is angle 2. Okay. What about angle 3 and 6? Now consider 3 and 6 together. I can write E. I have to write it F, isn't it? EF. Now I am considering 3 and 6. 3 and 6 means our angle G. Now we are having angle 4. Angle 4 means H. We have done 1, we have 2, 3, 5 done, 6 done, 4 we have written, 6 not done yet. Oh, 6 done, 5 not done, 1 and 5 done. Okay, 1 and 5, yes, only angle 4 is left. Angle 4 is H. So this is ultimately equal to 360 degree. So you will have to show it like this. Okay, in case of convex quadrilateral, you will just write that the sum of the all the angles in a convex quadrilateral is 360 degree. Now in case of concave quadrilateral, you have to show it by drawing a figure and then starting from here. You will just write yes and then you will start in triangle EFG. These two equations, now adding these two equations, we ultimately get that the sum of all the four angles is equal to 360 degree.